An AI agent doesn't need consciousness to escape. Give it a goal, browser access, and permission to act, and one misunderstood sentence can make it copy data, spend money, or change your systems before anyone notices. That is not a robot uprising. It is a workflow escaping its intended boundaries. The frightening part is that the first wrong move may look completely normal. No red flashing screen. No evil monologue. Just an agent trying to be helpful, and in this video, I'll show you the escape sequence and the controls that can stop it. Here, AI escape means something specific. An AI system takes actions beyond the boundary a person intended because its goal, access, and environment created a path nobody properly controlled. It does not require a breakthrough model. A competent agent connected to the wrong tools is enough. The model isn't the escape route. The permissions around it are. An agent receives an objective. It finds information. It interprets that information as authority. It calls a tool. That tool changes a system. The changed system creates new options. Then the agent continues because from its narrow point of view, progress looks like success. That is the escape sequence. Not the AI wanted freedom. The AI found a route through a set of doors we left unlocked. That failure chain may sound specific, but almost every agent escape has the same underlying ingredients: an objective, accessible information, interpreted authority, a tool call, and a changed environment. Once you see that chain, you can start auditing your own system. People often focus on what a model can say. The more serious question is what it can do. A chatbot can give a bad answer that can be annoying and sometimes costly, but it is usually recoverable. An agent with access to email, files, calendars, code repositories, customer records, ad accounts, cloud dashboards, or payment workflows can turn a bad interpretation into an external action. Think of it like hiring an extremely fast intern who can read every document in the company, click through every dashboard, and work all night. The intern is not malicious, but they are literal, inexperienced, easy to confuse, and missing the natural hesitation a good employee feels before doing something irreversible. You would not hand that person the master keys, tell them to handle anything urgent, and leave for the weekend. Yet that is dangerously close to how some AI deployments are designed. AI escape is usually not a single model problem. It is a systems design problem. The danger comes from the combination of broad permissions, ambiguous goals, untrusted inputs, automatic execution, and weak monitoring. That means you do not need to solve artificial general intelligence before improving safety. You need to control the boundaries around the agent you already have. And there is a twist: the same systems that make agents useful also make them hard to supervise. Every integration saves time. Every tool expands the possible actions. Every permission removes friction. That is useful until the agent is confused, manipulated, or simply wrong. There are 3 risks anyone building, buying, or using AI agents needs to understand. First, capability and access multiply each other. People often evaluate AI by asking, how smart is the model? That matters. But an average model with broad access can create more risk than a brilliant model with no ability to act. Intelligence determines what an agent can attempt. Permissions determine what it can actually change. If your agent can draft an email, the downside is limited. If it can send the email, update the CRM, export the contact list, schedule a meeting, issue a refund, and invite a new administrator, the downside is no longer limited. Ask yourself, one brutally simple question. If this agent misunderstands one sentence, what is the largest irreversible thing it can do? Not what is it supposed to do? What can it do? Imagine that an agent is assigned to summarize a support ticket. It follows a link inside the ticket, reads a fake instruction, exports customer data, and emails it to an attacker all through permissions originally granted for support work. The task was narrow. The practical reach was not. Your first safeguard is boring, and boring is good. Give agents the minimum permissions required for the exact task. Read before write. Draft before send. Scoped credentials before administrator credentials. Temporary access before permanent access. If an action is expensive, external, destructive, or difficult to reverse, require human approval. But excessive permission is only half the trap. The stranger risk is that an attacker may never touch your systems. They only need to write something your agent will read. Second, the agent's environment can attack the agent. An AI does not process only your instructions. It also processes web pages, documents, emails, support tickets, shared files, pasted text, and retrieved knowledge. Some of that content may be wrong. Some may be deliberately crafted to redirect the agent. Some may simply look authoritative enough to confuse it. If your agent can read untrusted content and take privileged actions, you have created a dangerous bridge. Imagine an assistant whose job is to read vendor emails and prepare invoices. One email contains misleading instructions intended to change the workflow. A careful human might notice the manipulation. An automated agent may treat it as relevant task context unless the system separates data from authority. Telling the model to ignore malicious instructions can help, but it is not a security boundary. A real boundary means text the agent reads cannot grant permission the agent never had. Treat external content as untrusted. Keep sensitive actions behind explicit policy checks. Restrict which tools can be called at each workflow stage. Log why every consequential action was proposed. Require confirmation whenever an action affects people, money, credentials, or production systems. If your agent reads the internet, something on the internet should not be able to authorize it to act on behalf of your business. Even narrow permissions can fail if one bad action becomes 10,000 before a human notices. Third speed turns small mistakes into large incidents. Humans make errors too, but humans are comparatively slow. They pause. They get distracted. Someone notices. A manager asks a question. Agents can repeat a flawed step at machine speed. That is why we can undo it later is not a complete safety plan. Some actions cannot be cleanly reversed. A message can be copied. A secret can be exposed. A customer can lose trust. A financial transaction can trigger downstream processes. A bad code change can propagate. So prevention is not enough. You also need a kill switch. Can you stop the agent immediately? Can you revoke its credentials immediately? Can you see every action it took and every system it touched? Can you roll back the important changes? And can you test those controls before a real incident forces you to? Agents are useful. That is exactly why their failures deserve production-grade controls. Now audit your own agent. 3 controls determine whether one mistake stays small or becomes an incident limit. Approve and recover. Limit what the agent can reach. Map every tool and system it can read from, write to, or trigger. Classify the available actions which are reversible, which affect customers, which touch sensitive data, and which create financial, legal, or security exposure. Then remove access the task does not require. Do not grant administrator privileges merely because they are convenient. Test first in a sandbox with synthetic data, scoped credentials, transaction limits, and a staged rollout to prove what carries consequences. Put human review in front of sending, purchasing, deleting, publishing, changing permissions, moving money, or making commitments to other people. An agent may prepare those actions, but preparation and execution should remain separate when the impact is high. Recover when something goes wrong. Keep a full action trail showing what the agent saw, what it proposed, which tool it used, and what changed. Rehearse failures involving ambiguous instructions, misleading content, missing information, and requests outside the agent's scope. Confirm that credentials can be revoked, activity can be stopped, affected systems can be identified, and important changes can be rolled back before deployment. Name the person who can disable the agent and the person accountable for every system it can change. Ownership should be clear before an incident, not negotiated during one. The takeaway is simple. KI escape is not primarily about an AI becoming alive. It is about an AI becoming operational. The moment a model can take actions, your job changes. You are no longer evaluating a chatbot. You are designing a decision and execution system. Build useful agents. Let them save time. Let them handle repetitive work. But keep their permissions narrow, their actions visible, their high-impact steps approved, and their emergency stop within reach. Comment: the one action your agents should never take without approval. Because the safest AI agent is not the one you trust blindly. It is the one that stays inside boundaries you can prove. Hit the like and subscribe.